Welcome to Week 5 of Introduction to Algebra. This week's topics are solving for a variable and consecutive integer problems. First, we're going to talk about solving for a variable. Many formulas that you'll encounter in math and science have more than one variable. Sometimes we want to solve the formula to find a particular variable. So we often need to rearrange the formula in order to solve for the variable we want. There are many formulas that you will encounter in math and science. I have selected just a few here to use as examples. You do not need to write all of these down at this time. I'm going to show you how to use each of these formulas in the notes coming up. Solving for a variable. The first formula we're going to look at is the circumference of a circle. The circumference of a circle is c equals 2 pi r, in which r stands for radius. In these examples, we're going to solve for the highlighted variable. So in this case, I'm going to pretend that I happen to know the circumference of a circle, and I would like to find the radius instead. So I want to solve my formula to be r equals. If I start with c equals 2 pi r, this means 2 times pi times r. The inverse of times is divide. So to solve for this r, I'm going to divide both sides by 2, and simultaneously I can divide both sides by pi. On the right side of my equation, 2 divided by 2 is 1. Pi divided by pi is 1, and I'm left with just r. So my rewritten formula would be r for radius equals c divided by 2 times pi. The next formula I'm going to take a look at is the perimeter of a rectangle. In this case, P is perimeter, L is length, and W is width, and I'd like to solve for the width. Note that this formula uses parentheses as grouping symbols. So I need to take care of the things that are outside of the parentheses first. To solve this equation for W, first I'm going to get rid of this 2 times everything by dividing both sides by 2. This gives me the rewritten formula, P divided by 2 equals length plus width. Since I would like to solve for W, I'm now going to subtract the length from each side. It doesn't matter that I don't have like terms. I'm simply going to move the variable and keep it as it is. So I now end up with P divided by 2 minus the length equals the width. And that's my new formula. It can be written as width equals P, or perimeter, divided by 2 minus the length. In my third example, I'm going to use the area of a triangle. The area of a triangle is equal to 1/2 the base times the height, and this time I would like to solve for the height of the triangle. So if I have area equals 1/2 base times height, there's a couple of different ways I can get rid of this 1/2 times base times height. I can divide both sides by a half. That would be the inverse of times. But remember, dividing by a half when you have a fraction is the same as multiplying by the reciprocal. So I'm going to multiply both sides by 2. And some of you might like to think of this as 2 divided by 1, in which case 2 times a half cancels out, and my new rewritten formula looks like 2a equals the base times the height. And I'm halfway there. I want to get the height all by itself. Since I have base times height, I'm going to use the reciprocal, or I'm sorry, not the reciprocal, but the inverse of times, and I'm going to divide both sides by b, and my newly written formula would be that the height equals 2 times the area divided by the base. I've now rewritten this common formula to solve for height. Take a moment to jot those down before we move on. Another very common formula is the distance formula. I am quite certain that you'll be using this formula in science this year. The distance formula says that distance equals rate times time. And in this case, I would like to solve for rate. So if I start with d equals RT, RT means the rate times the time. So to undo times, I will use the inverse, and I will divide both sides by time. In doing so, t divided by t is 1, and I am left with rate equals distance divided by time. When you think about this, this is something we use all the time. You frequently probably use the expression, for example, 70 miles per hour. And if you think about what that really means, 70 miles per hour is a rate. We call that the rate of speed. And what that really means is that 70 miles per hour equals 70 miles, which is a distance, divided by 1 hour, which is time. So that's a really common example that you probably use on a daily basis. Our next example is the volume of a rectangular prism. You probably more commonly call it a box. So you could kind of picture a shoebox as you think about this formula. The volume equals the base times the height times the length. If I want to solve this formula for base, I'm going to have to undo the times height and times length. So to undo multiply, I would divide both sides. I can divide both sides by height, and really at the same time, I can divide by length as well. So when I rewrite this, I come up with the volume divided by the height times the length is equal to the base. And frequently people like to put the variable by itself on the left, so I could say that the base equals the volume divided by the height times length. These two equations are equivalent. We have two more examples involving solving for a variable. The next is a really common one. We see it all the time. It's a very popular equation, E equals mc squared. But if you asked a common person on the street what everything actually stood for in that equation, I'd be surprised if many knew. But in fact, E is energy, M stands for mass, and C is actually the speed of light. So if I have E equals mc squared and I wanted to solve for M, the mass, I need to undo mass times the speed of light squared. So to undo times, I'm simply going to divide. I have c squared, and I can rewrite this to be E divided by c squared equals mass, or we could say mass equals the energy divided by the speed of light squared. Another really common formula, one that I'm sure you'll probably use in science throughout high school and maybe even in real-life applications, is the conversion of Fahrenheit to Celsius. You might have noticed that in science class we always use Celsius. We say that water freezes at 0 and boils at 100, but when you're at home you use Fahrenheit, and we say that freezing is 32 degrees and water boils at 212. And that's because we're using two different scales. So if I have the formula Celsius equals 5/9 Fahrenheit minus 32 degrees, and I want to solve for Fahrenheit, I have several steps to go through. The first is that since I have 5/9 times everything in the parentheses, because these parentheses are acting as a grouping symbol, I need to get rid of this 5/9. I could do two steps. I could multiply both sides by 9, and then I could divide both sides by 5, or you may recall that you can always multiply by the reciprocal. So I could multiply both sides by 9/5. So when I multiply both sides by 9/5, on this side I'm going to have 9/5 times C. 9/5 and 5/9 will cancel out, so this will equal Fahrenheit minus 32. And I'm almost done. I want to get the Fahrenheit by itself, and right now I have Fahrenheit minus 32. So the inverse of subtract is add, and I'm simply going to add 32 to both sides. So my final answer looks like 9/5 C plus 32 is equal to F. Or I can rewrite that as Fahrenheit equals 9/5 Celsius plus 32. And that's the last example that we are going to do on solving for a variable. Our next topic is consecutive integer problems. First thing you need to know are what are consecutive integers, right? They are integers that follow each other in order. So often we think of them as integers on the number line that follow each other. So for example, if I start with the number 4 and I want the next integer, it would be 5. If I start with the number 97 and I want the next integer, it would be 98. There are several different types of consecutive integer problems. The first example we're going to do is to find consecutive integers. So we have the problem, 2 consecutive integers add up to 43. What are the integers? The first step in solving this type of problem is to name the first integer. Since we don't know the first integer, we'll just call it n. You can use x or b or whatever variable you like, but I'm going to use n for number. Second step is to name the second integer. I don't know what the first one is, but I know that the next integer is going to be one number, one unit further down the number line. So if I call the first one n, then I have to call the second one n plus 1. My third step is to write an equation. So now I have the first integer plus the second integer equal to 43, because the problem tells me that the 2 consecutive integers add up to or equal 43. Next, I'm going to simplify. So I get 2n plus 1 equals 43. And now we have a simple two-step equation. So I can proceed to solve the problem. I would subtract 1 from each side, and I would get 2n is equal to 42. Divide both sides by 2, and I come up with n equals 21. It's very tempting to stop at this point, but I'm not quite done. Remember the original question, what are the integers? They want both numbers, so the answer is that the integers are 21 and 22. Another common type of consecutive integer problem is when you're asked to find consecutive odd or consecutive even integers. So in example 2, we are told that the sum of 2 consecutive odd integers is 20. What are the integers? So my first step is the same. I'm going to name the first integer n, because I don't know what it is. But this time, I'm looking for the next odd integer. So I would actually have to move 2 units on the number line. So for example, if I started with the odd number 3, and I want the next odd integer, it would be 5. So instead of adding 1 to get from 3 to 5, I have to add 2. Third step is the same, write an equation. So now I have n for the first integer plus n plus 2 for the second integer equals 20. I simplify to get 2n plus 2 is equal to 20. And then I have a two-step equation which I can solve by subtracting 2 from both sides to give me 2n is equal to 18. I'm going to divide both sides by 2 and find that n equals 9. But remember, you're not done yet. They want to know both integers. So my answer is that the 2 integers are 9 and 11. The first one is represented by n, which turned out to be 9. To get the second integer, it would be n plus 2. So 9 plus 2 is 11. Thank you for watching this YBark production.